When I was 9 years old, we got our first computer. It was a present from my aunt, and my sister and I were truly excited about this new device, but also just a little bit scared about this big new fancy machine. Nevertheless, we started to explore every possible program, every setting that we could find, just out of pure curiosity to see what this technology can do for us. Little did we know that years later, computers would totally change our lives. So who of you can imagine a life without your laptop or your smartphone? How would your day even start? So computing devices, together with the internet, have provided us immense capabilities that we could have never imagined. I mean, this video stream right now is streamed to people just on the other side of the world. When it comes to robotics, we are 9-year-olds right now. As researchers, we explore the capabilities and opportunities that this technology provides us. And there's a lot of excitement, a lot of technical advances, but also a lot of uncertainty about this technology. So if you think about robot, what kind of image comes to your mind? Does it look like this? So Terminator-like scenarios, together with the media telling us that robots take our jobs and take over the world, is kind of what resonates with a lot of people. The image that I have about robots is different. For me, robots are just another device, just another tool, like computers, that enable us to reach bigger audiences, to simplify our lives, and in general, empower us. So, and this is much closer to the original word of robot, which means forced labor or just worker. Robots can be tools, devices that work for us, and we should build them to work for us. So let's see where robotics is right now. So to be honest, the majority of robots are in confined industrial spaces. You usually don't see them. They are extremely good at doing specific tasks with high accuracy and very high speed. So these robots, we could provide them the very precise instructions to do their task perfectly. But this was only possible because the environment they work in is very predictable and known to us. So as programmers, we can provide very precise instructions. However, these robots, while they are good at doing repetitive tasks, they are not able to learn new tasks on their own or adapt to new situations. So in the future, we imagine robots to adapt and learn on their own. And that would allow them to work in much more complex environments alongside humans and in changing environments where things are not known to us programmers ahead of time. So you see here an example of a robot that enables a paraplegic person to walk again while the person was bound to the wheelchair before. So it can provide us capabilities that we wouldn't have otherwise. Other examples are like a rover on Mars. It has to work in an environment where no human has ever been before. So how could we provide this robot the instructions that it needs to perfectly do a task? So it's bound to fail if it is not able to adapt to this new environment. Other examples include robots going into dangerous areas like helping us to fight fire or monitor nuclear power plants. But maybe the most common example that you are all aware of is autonomous cars. Just imagine what an autonomous car experiences every day. So the road conditions vary so much that as programmers of robots, we are not able to describe the physics and the behavior of the robot ahead of time for all the vast different road conditions that a robot could experience. This can range from snow, ice, and just a simple sunny road. And instead of the robot just driving very conservatively all year around, we wanted to drive and adapt to the situation that it encounters. So what we imagine is that the robot actually, just in the first few seconds of driving, adapts to the road conditions and drives as optimally and efficiently for the given situation. So in our research, we work on fundamental learning algorithms that would enable a huge new range of applications where robots actually have to go into environments that they don't know ahead of time. And I imagine these new robots to become tools that empower and elevate the lives of each and every one of you. So how did I get into this topic in the first place? So I've been basically an applied mathematician till my master's. I was writing equations and proving theorems. But not many people did understand what we were doing. So for my PhD, I was looking for a topic where I can apply my mathematical knowledge, but where my work has a more tangible, direct, positive impact on society. So let's see some of the examples from our lab. So one of the robots we work with is this ground robot. It has a stereo camera, so it can view the world and perceive the environment like we humans do through vision. When we task this robot to drive a previously seen path just at a reasonable speed, that's what happens. So the robot drives off the path actually into a pile of rocks and, be a danger for the environment and possibly for itself. So what happened here? Really, what happened was that we as robot programmers could not provide the precise instructions that the robot was requiring to optimally and safely do this task. And the reason is that the robot dynamics, as the robot drives faster on this sandy ground, are very difficult to understand and describe with mathematical equations. So with our prior knowledge about the robot's behavior, and our prediction of its path following, it was not able to achieve this task. So instead, we enable this robot to learn, just similar to how human drivers learn. And that means it starts at a low speed, where our mathematical equations are still reasonably accurate. And then it gradually increases the speed, and it uses the experience from its previous runs to actually achieve the task we ask it to do in the first place. So here you see the robot. It starts at half of the speed where it previously failed, and at this speed it can still do the task safely. It uses this experience to drive at a higher speed. And finally, it can do the task that it failed before, driving at 1 meter per second. And here you see the complete pass. So our learning algorithms enabled the robot to do a task that it wouldn't be able to do otherwise. So we increase the set of capabilities of this robot by enabling it to learn on its own. We take this a step further in our research and also look at flying robots. These are so-called quadrocopters. They have 4 rotors. They are independently controlled, and as such, they are highly maneuverable. With these flying robots, we explore learning technology in 3 dimensions. And there's a particular issue with flying robots that is very interesting for us. If those robots make a mistake while learning, they would fall out of the sky. So we can only allow very small mistakes because we always want to guarantee safety for the robot, but also for the humans around. So if we enable this robot to learn, it looks a little bit like a baby that starts walking. So for a baby, initially the parent holds it upright and teaches it how to walk. And if the parent is confident enough that the baby can kind of grasp how this task works, it lets the baby go, and the baby starts to walk on its own. It may be clumsy, it may fall down once in a while, but through practice, it will be able to eventually walk through every possible terrain. We use a similar technique for our flying robots. So instead of a parent, we have a human pilot that flies this vehicle just for 10 seconds. And from this flight experience, the robot has enough information to keep itself autonomously in the air. This may still not be perfect, and in fact, it would look like this. So this is just after 10 seconds of data. The vehicle has a reasonable good grasp on how to move, but it's still clumsy, and it takes a while to kind of get to the desired location. But while it is doing this and while it is flying, it gathers more and more experience, and that enables it to eventually fly very confidently. So by just having 30 more seconds of data, you see below the vehicle is now flying confidently and quickly. So while this was more a proof of concept example, it shows you that we can enable robots to learn while never jeopardizing safety, because in contrast to the baby parent example, our algorithms guarantee that the vehicle would never fall during the learning process. But we can even go further beyond this kind of proof of concept example and teach a robot to do a task again that it wouldn't be able to do without learning. And this is doing a slalom maneuver as quickly as possible. So here the vehicle learns above the poles from rough instructions that we gave it. It tries to optimize its actions to achieve the desired outcome. And after 3 iterations, it's able to actually fly through the poles. And I can tell you, without learning, it was crashing into the poles. So we can do this for different configurations, and you see the high speed this vehicle is flying, which is something that is very difficult for us to mathematically describe and understand. So beyond these examples, you can imagine that robotics technology can provide us with a vast range of possibilities for future applications. And just to give you one more inspiring video, we can also fly autonomously a swarm of robots in a coordinated way. And this may be useful for search and rescue operations where robots have to quickly find victims in a disaster area, but it may also just be for entertainment. As we enable robots to learn, they become more capable and more powerful and actually safer tools for us to use. As computing technology has had a major impact on our lives, I imagine robot technology to be as important and disruptive. And as and I'm sure you, can't imagine a life without your computer or your smartphone, soon you may take it for granted that an autonomous car takes you wherever you want to go. So let's not be afraid, but instead be 9-year-olds and try to embrace and explore this new technology and find out how it can empower and elevate our lives.